Hey guys, I'm so sorry this video took so long to put up. It was a combination of me being sick and our curriculum being a little out of order. But I'm going to skip through some things, and I know your notes don't look like what you are accustomed to taking, but I want you to keep in mind that I'm going to try to explain everything I want you to write down in every section, and what you really need to write down are the things that are in color, and they'll be in lots of different colors. So just write down the things that are colored. So let's start with the point that says, describe the structure of atoms. So here's what I need you to write down. Write down that protons and neutrons are joined together in the nucleus. So protons and neutrons are joined together in the nucleus. And electrons fly around freely in what we call the electron cloud. Again, electrons fly around freely in the electron cloud. And then off to the side, if you could draw just this little diagram with some pluses for your protons and just some little circles for your neutrons, and then just put some electrons with a little negative sign around that nucleus, that would be what your atom looks like. Excuse me. Don't forget, at any point in time, you can pause the video or rewind or whatever if I'm moving a little too quickly. I'm going to kind of talk fast because I don't want the video to be stretched out forever. Okay. So now we're on the bullet point that talks about subatomic particles. What I want you to do for this bullet point is draw this diagram that I'm circling with my laser and label it exactly as you see it here. So again, draw this diagram, the one I'm circling with my laser, and label it exactly as you see it on the picture. And next to it, I want you to write, stable atoms have the same number of protons and electrons. Their protons equal their electrons. Now for the bullet point that says, what causes chemical reactions to occur? I want you to write, excuse me, that electrons are gained, lost, and shared between atoms. So what causes chemical reactions to occur? Electrons are gained, lost, and shared between atoms. Right, so you don't necessarily have to write anything down in this slide. We've kind of already written what we need. But I just need you to remember that chemical reactions take place because we're always losing, getting, and sharing electrons. It's like you have candy in your pocket. You can give the candy away, you can keep it for yourself, or someone else might give you candy. That's how electrons and atoms behave. Atoms might choose to give their electrons away or keep them for themselves, but that makes a chemical reaction happen. Excuse me. So now we need to talk about the bullet point that says steps to draw an atom. So you're writing down, I'm going to kind of box off using my laser. This is what you're writing down. So in the steps to draw an atom, we always draw the nucleus in the middle. So the nucleus is always in the middle. And then each energy level, because that's where your electrons are, is shown as a circle. So you just draw circles around that nucleus. Okay, now to show the electrons, you can either use dots, like I've shown here with my laser. I'm showing you where those dots are. Or you can use crosses. Like some people like to use X's, and I'll show you what those look like. It would be the same kind of diagram. We just put an X like that instead of a dot. So it doesn't really matter. But that's what they mean by X's. So we use either dots or crosses or X's to represent the electrons, to show where the electrons are. So again, this is what you're putting in the bullet point that talks about steps to draw an atom. Okay, now we are on the bullet point that talks about sublevels. So this is what you're writing down for sublevels. Each energy level is broken down into a smaller level called a sublevel, and there are 4 of them. Okay, so you need to write that each energy level is broken down into sublevels and that there are 4 of them. Their names are S, P, D, and F, and they can each hold a different number of electrons, so you need to write this down as well. S only holds 2 electrons. So again, S only holds 2 electrons. P holds up to 6 electrons. P holds up to 6 electrons. D holds up to 10 electrons. D holds up to 10 electrons. And F holds up to 14 electrons. F holds up to 14 electrons. So again, 4 energy levels or sublevels, S, P, D, and F. S holds 2, P holds 6, D holds 10, and F holds 14. Part of the way that our periodic table is arranged is based on these sublevels, S, P, D, and F. So the different sections of the periodic table tell you what kind of sublevels those elements have. So if you look on your notes, you have a tiny little periodic table off to the right-hand side. I'd like you to label these sections on your periodic table. You can just draw boxes and then write the letter in the middle. So S would be just these first 2 columns. D would be everything that's kind of like on a shorter level, so everything down here in this region. And P is everything that's up here on the other side. So S is on the left, D is in the middle, and P is on the right. And then the last 2 bottom sections would be F. So every energy level, like I just told you, has a sublevel. And there's a special way that we fill them in. I'm sorry that this is all like weird. So now you're writing down under the section that says filling in electrons. So S can only hold 2 electrons. That's your first energy level. So you're writing down what's in yellow. The second energy level is S and P. Remember I said they're sublevels? So energy level number 2 has 2 sublevels, S and P. Together they can hold 8 because S by itself holds 2 and P by itself holds 6. So 2 plus 6 equals 8. So the second energy level holds 8. The third energy level is S, P, and D. Excuse me. And all together, the third energy level can hold 18 because S holds 2 by itself, P holds 6 by itself, and D holds 10 by itself. 10 plus 6 plus 2 equals 18. So that's the first 3 energy levels and how many electrons they can hold. So all of this information needs to be written down under the bullet point that says filling in electrons. Okay, now you probably are wondering, why didn't we talk about F? We don't talk about F because F doesn't have any effect until the 6th energy level. We just care about the first 3 for right now. So here's an example for filling in electrons. We are looking at the element phosphorus, which on the periodic table is P. Phosphorus has an atomic number of, has an atomic number of 15, which means that it will also have 15 electrons. So we need to figure out how many energy levels phosphorus is going to have around its nucleus. So that's step one. Step one is figure out how many electrons will be in the atom. And you get that again from the atomic number. So we draw our first circle, and our first circle would be S. I'll label that for you. And S can only hold 2 electrons, so there are our 2. 1, 2. So that leaves us with 13 electrons that we have to put someplace. So now we draw a second circle. Don't forget the second energy level, or circle, is S plus P. So this one can hold 8, because S holds 2 and P holds 6. So, excuse me, we put in our first 2, 1, 2, and then we can put in 6 more. 1, 2, 3, 4, 5, and 6. So far we've put in 10. That still leaves us 5. We can't fit any more in S or S plus P, so now we need to do one more. We need to do another energy level. Excuse me. So our next energy level is S plus P plus D. This one can hold up to 18. We have 5 left, so we put all 5 in here. 1, 2, 3, 4, 5. And that's what an atom of phosphorus would look like if we drew it. So on your notes at the very bottom, you have a section that says, determine how many electrons are in each of the elements below. Use your periodic table to figure out the atomic number of the element, then write that down because that will be how many electrons it has. Remember the 8-man foldable? 8-man says that atomic number is the same as proton number, which is the same as electron number. Please pause the video until you're finished doing that and then hit play again. Okay, you should be back with me, and we're now on the back page of your notes where you have the very same diagrams that I have on the slide, except my own are filled in. So what I want you to do is fill in the correct number of electrons for each element that I gave you. So let's start with hydrogen. Hydrogen has 1 electron, so the only orbital we will need would be an S. And there's our 1 electron. Boron has 5, so we would actually need 2 because we know the first one, we know S can only hold 2. So we need S and P. And we would put our first 2 in S, and then we put our other 3 in energy level number 2. Next is nitrogen. Nitrogen has 7. So we would need S and P. Don't forget, S and P can hold up to 8. Excuse me. Excuse me. Oh, I'm so sorry. So here are our first 2. And then 1, 2, 3, 4, and 5. So all 7. Next is sulfur. Sulfur has a lot. So sulfur is going to need S and P, and D. So 3 energy levels. So S and P, and D. Don't forget, the first energy level can only hold 2. 1, 2. The second can hold 8. 1, 2, 3, 4, 5, 6, 7, 8. The third can hold 18, but we only need it to hold 1, 2, 3, 4, 5, and 6. So go ahead and draw these dots in so that your pictures look like my picture. So atoms can, and always do for the most part, start with the same number of electrons as protons. But earlier I told you that electrons are kind of like candy. You can keep them for yourself, you can give them away, or you can share them with someone else, or you can completely get some from someone else, or you can completely lose them. They're always moving around. So it means that the electron number doesn't always stay the same. So now we're going to flip back over to the front of your notes, and we're going to fill in the bullet point that talks about valence electrons. Okay, so this is what I want you to write down. Valence electrons are the electrons in the outer energy level. So again, valence electrons are the electrons in the outer energy level. The very last circle. So in this molecule, we'd have one valence electron. In this atom, In this atom, we'd have 1, 2, 3, 4, 5 valence electrons. In this atom, we'd have 1, 2 valence electrons. So again, it's just how many electrons you have in the very last energy level, the very last orbital, the very last ring, the very last circle, however you can remember that. So now you need to flip back over to the back of your notes, and figure out how many valence electrons are in each of those pictures that I've shown you. Alright, I'm back. Hopefully you got this figured out. So in neon, there are 8 valence, carbon has 4, lithium has 1, and chlorine has 7. Again, it's just how many are in that last ring. So I know this image looks weird, like the periodic table's all flipped around, but don't even worry about that. We'll do that together in class. What I want you to pay attention to is this sentence that's written above, where it says valence electrons for an element can be predicted using the periodic table. So under valence electrons, go ahead and write that. I want you to write that they can be, that valence electrons for an element can be predicted using the periodic table. So you can use the table to figure out how many electrons are in that last ring or shell of that element. We're still under valence electrons, and this time I want you to write that elements that have the same valence have the same physical and chemical properties. So again, elements that have the same valence, electrons, have the same physical and chemical properties. Again, elements that have the same valence electrons, so elements that have the same valence electrons have the same physical and chemical properties. They behave the same way. Okay, so we've skipped some slides. I want you to go ahead and flip back to the back of those notes, and you'll see a little grayed out box. And I want you to use your periodic table and figure out how many valence electrons are in each of the elements given. Actually, no, I don't want you to do that. Now we're talking about Lewisdot diagrams. So we're filling out the bullet point that says Lewisdot diagrams. What I want you to write is that Lewisdot structures or diagrams show the number of valence electrons in an atom. And then I want you to draw this as an example. So hydrogen would be the element, and it only has one valence electron, so we put 1 dot around the hydrogen. Right, so again, under Lewisdot diagrams, you're saying that they show the number of valence electrons in an atom. And the way we do that, and I want you to write this out so that you have the example, is we put the element symbol and then how many valence electrons. So in this case, it's just hydrogen and 1 dot because it only has 1 valence. Now on the back of your example, I want you to circle which ones have the correct number of valence for each of the elements given. So here the example is lithium. Lithium should only have 1 valence electron, so this would be the correct Lewisdot structure. The next one is oxygen. Oxygen also only has 6 valence electrons, so this would be the correct structure. And when we come to class, I'll explain why we form the dots the way we do. We don't just put them any old how, we put them in a very specific order. So I'll show you how to do that in class. Okay, now we're filling out the bullet point that says the octet rule. So the octet, and hopefully you know that octet means 8. So the octet rule, this is what you're writing down, says that atoms are most stable, they're most likely to stay the way they are, when they have 8 valence electrons. So they need to have 8 electrons in their outer shell. To have 8 electrons, it means that both their s and their p sublevels are full. So you're writing down this part and this part under the octet rule. Okay, this next section goes under helium, the special case. So I want you to write that group 18, also called the noble gases, have 8 valence electrons. So again, you're writing group 18, called the noble gases, have 8 valence electrons. So because they have 8, it means that they're stable. They don't react. They don't have any reason to give any of their electrons away or take anyone else's electrons, or even to share electrons. But there is one noble gas that's not found, excuse me, sorry about that. So there is one noble gas that doesn't actually have 8 electrons, and that would be helium, up at the top. Helium only has 2 electrons. Hold on, now that I've written all over it, you can't see it, but helium only has 2 electrons. And I told you that these guys all have 8 and they're really, really stable. So why is helium special? That's what we're about to talk about. So why is helium a noble gas? Helium only has 1 energy level. Okay? And the first energy level can only hold 2 electrons. So because helium has 2 electrons, technically it has a full energy level, which makes it stable. And again, stable means that it's not going to lose or share or gain electrons. It has exactly the number it needs. So what are you writing down? You're writing down that helium only has 1 energy level. It only needs 2 electrons, so it's full. It's not going to gain, lose, or share electrons. So that's why helium is a noble gas. Okay, I'm sorry again that this video took so long to get up to you. Don't forget, we have a test on Tuesday. Make sure you're studying that review and you're going over what I made you highlight in class and all of that. And we will deal with what we talked about in this video the next time I see you. All right, so have a great weekend. Bye.